Hi, I'm Matthew Burchett.
I'm Gene Kranz. This is Behind the Wings.
Nice vest.
Thank you.
Now, I say this a lot, but how cool is this? This is Lieutenant Zach Farrell, Dr. Janet Kavandi, the amazing Gene Kranz. You've never seen aerospace like this. In 1962, President Kennedy challenged NASA to send a man to the moon and back before the end of the decade.
We choose to go to the moon in this decade. And
under the direction of Vice President Lyndon B. Johnson, Congress appropriated funds and NASA expanded its programs to achieve President Kennedy's vision. Two significant projects came before Apollo to gain insights on space travel and survival. The first was Project Mercury, which sent the first American into space in 1961. 6 astronauts were successfully launched during the Mercury program for a total of 54 hours in space. From 1965 to 1966, Project Gemini continued to develop techniques for long-duration space travel during 10 space missions. The Gemini spacecraft carried a 2-astronaut crew and advanced NASA's understanding of space rendezvous and docking, re-entry and landing methods, and the effects of longer space flights on astronauts. The first Apollo missions began in 1967 with Apollo 1, which was a flight test for the Apollo Command and Service Module. Tragically, a cabin fire during a launch rehearsal killed all 3 crew members, leading NASA to suspend manned Apollo flights for 20 months while the module's shortcomings were addressed. Over the next 2 years, Apollo 4 through 10 continued to prepare NASA for achieving the goal of landing a man on the moon before the end of the decade.
Very, very fine-grained as you get close to it. It's almost like a powder.
On July 20th, 1969, history was made as Apollo 11 astronauts Neil Armstrong and Buzz Aldrin successfully landed on the moon's surface, while astronaut Michael Collins orbited overhead. After Apollo 11, NASA conducted 6 more missions to the moon with Apollo 12 through 17. Only Apollo 13 failed to make a lunar landing when an accident en route to lunar orbit forced the crew to return to Earth. The last mission, Apollo 17, occurred in December 1972. Over the course of the Apollo program, a total of 12 astronauts walked on the moon where they conducted increasingly sophisticated scientific studies, yielding new insights into the evolution of the moon. Each mission explored new areas of the lunar surface and left behind scientific instruments that continue to send back data to Earth years later. Now, let's talk to someone who made Apollo history. He was NASA's flight director for 9 Apollo missions, including Apollo 11, the amazing Gene Kranz. In 2019, we celebrated the 50th anniversary of the Apollo moon launch, Apollo 11. What is it like to think back on that time?
It's really an opportunity to actually think about what America was in those days. You know, the space program was just one of the things that was moving. You had the Civil Rights Movement, you had the Peace Corps. You know, all of America was in the process of moving, and they're making something happen. And this is, I think, the change in today's world. People want to watch things happen as opposed to getting involved. And for me, it was basically I was 50 years younger the day I walked into Mission Control. I mean, it was just like I was back there that day, at that time, in that place, with my team and with the leaders I had. This was a time of leadership within our nation, time of unity within our nation. We were one moving towards a goal established by President Kennedy. Take the man to the moon, get him back safely, and do it within the decade. Marvelous challenge.
When you guys started the countdown and all that's associated with it, did you have any idea what it was going to do for the human race?
We were so busy in those days, we were flying just generally about a mission every 2 to 3 months. So as soon as we finished one mission, we basically debriefed, had a few days break, time off, went into training, began the next mission. I don't think any of us really recognized the impact that we would have. We'd go home and we'd read the newspaper and say, God, that's pretty neat. Okay, and they say, yet I think about my people. My people were the ones that I just loved them. They were young pups, young kids, basically who were on the console, stepping up to one of the greatest responsibilities. And they did it, and they did it perfectly.
Do you miss it?
Yes, I do. I look at it, you know, I sort of connect it to the Panama Canal. The Panama Canal, when it was built, tied two oceans together. Apollo 11, when he landed in the moon, tied two worlds together, Earth and deep space. And I think this was sort of a challenge to the people that we have today. Continue to press, explore, demand as much as you can of yourselves. Make things happen. Get involved.
Where do you see us, or where would you like to see us in the next 50 years in space travel?
I think there's many answers to that question. I think the first thing I'd like to see is this country come together as one again. Because I think that the key to our future is establishing the unity necessary to be successful in whatever you set out to do. I would like to see us back on the moon with stations there, permanent stations on board the moon, serving industrial, economic, during military purposes right on the line. And I guess you shouldn't say that, military purposes of the moon, but I think that we have to continue to address the use of space for all reasonable activities that we got there. Then once we have learned to live on the moon, we can then move further than that. We can move into Mars. We can continue this process of exploration, but before that, you have to learn to live in a hostile environment for an extended period of time. I talk about it as if camping. The first time you go out camping, you think about all those things you brought that you didn't need and those things that you forgot. It takes about 4 or 5 times to get that together. And I think that's one of the principal reasons to go back to the moon. I believe it to be, I wished I was 50 years younger and I could be one of the young pups in mission control today, living that kind of an experience all over again.
After my conversation with Gene, it was time to explore a state that was significant to the Apollo program and continues to push the frontier of space travel: Ohio. First stop, the small town of Wapakoneta. Now, if we're talking about Apollo, why am I sitting on the front steps of a house? That's because this house was the boyhood home of none other than Neil Armstrong, the first man to walk on the moon. The other thing that's really interesting is that he used to work for NASA at the Glenn Research Center, which at the time was called the Lewis Research Center. That's just up the road in Cleveland, and there is a ton of information there that I want to check out. So, let's get going. So we drove up from Wapakoneta, and now we're at the Glenn Research Center here in Cleveland. And I've got John Oldham, who's the exhibit specialist here on campus. Thank you so much. And I gotta say, I understand you're actually a fan of Behind the Wings?
Absolutely. Love the show.
Awesome.
That is a great job.
Gotta get that plug in.
job.
You heard
Always.
him here. He said we're doing a great job. So tell us a little bit about what Glenn Research has done for the Apollo program.
Sure. Well, firstly, the Glenn Research Center started as the Lewis Research Center. It was an aero center back in the 40s. We didn't become Glenn until 1999. That was in honor of John Glenn, hometown guy. And but in the interim, as Lewis Research Center, we were faced with part of the big challenges of Apollo. One of the things Lewis had been working on at the time was hydrogen fuels. Basically, we had to push a 363-foot tall, 7 million pound rocket and get it to 17,500 miles an hour in less than 100 miles. So the fuel problem was solved by the folks at Lewis with hard work, dedication, and they were the kind of the spear point of getting hydrogen under control that would later be used to enable us to do some missions. So there were 16 missions that flew prior to manned missions to the moon that Glenn was involved with, spacecraft like the Ranger spacecraft. Rangers were lunar probes that were not not quite capable of soft landing. They made hard landings, we'll leave it at that, on the moon. They sent back some very nice pictures on their way in. And in addition to that, we had lunar orbiter spacecraft that would stay in orbit around the moon and provide great photography and some data to help us kind of pick those spots where we would put ourselves eventually on the moon.
All right, John, you have a amazing set of toys, but this?
Yeah,
Come
this is the real
on.
deal. Yeah, so what we have here is an Apollo A7L. It is the basic suit to go to the moon in. This particular suit belonged to William Anders, who was the command module pilot for Apollo 8. Wow. It was not a flown suit, it was his flight spare, you know, bolt for bolt and stitch for stitch, identical in how they were made. They were form made for the astronaut. In this particular suit, you could not sit down. There's no stitching in there to allow you. If you remember Apollo 11, when Neil and Buzz landed, they were standing. When you landed in a lunar module, you were not sitting in a chair. There was no chair in the lunar module. So you couldn't even bend all the way because it would require things that would compromise the safety of the suit to the point where they decided to delete that.
So on the helmet,
Yes.
this does not look like the helmet that you see in all the photographs.
Sure. A lot of people believe that that big, beautiful helmet with the gold visor
Yeah.
was the actual pressure helmet for the moon. It wasn't. You have this pressure bubble that keeps this astronaut breathing nice breathable air. You don't want to take that out on the moon and take the chance of tripping and breaking it. If you had a hard hat, you could put over that, which is what they had. They called the Apollo helmet the LEVA, the Lunar Excursion Visor Assembly. And it was a hard hat that went over this and had a series of visors, that gold visor
Right.
that would lift. So that was
Okay.
over the top of this bubble. So you still required this.
Can I try that on?
Absolutely. Sure, we can make that happen. So you'll want to tilt it back and then back over your head just like that. There you are.
I love it. I sound like really cool in here.
Aside from this super awesome spacesuit, John had one more Apollo artifact to show me. Let's
Dive in.
But before we get to that, let's talk a little more about what's currently going on at Glenn. As one of 10 NASA centers around the country, Glenn is situated on 350 acres of land and contains more than 3,000 employees. Within their dedicated teams, Glenn's primary purpose is to research, develop, and test innovative technology for aeronautics and spaceflight. Need an example? Check this place out. This is the SLOPE Laboratory, also known as the Simulated Lunar Operations Laboratory. Part of their mission is to improve how we get around on other planets' surfaces, which explains the giant sandbox in the center of the room. It also explains this collection of unique tires. They have exact replicas of the tires used on the lunar rover, which were surprisingly light, and newer models that will support even heavier lunar vehicles. Another lab doing interesting work is the Exercise Countermeasures Laboratory, which evaluates exercise devices that astronauts use in space. This lab simulates the zero gravity of space by hanging test subjects from the ceiling and having them run on this vertical treadmill. Unfortunately, I wasn't allowed to test it out, but I did try on this super groovy harness that was developed at Glenn and is used by the astronauts in the International Space Station. Ever been told it's not rocket science? Well, this lab is rocket science. Specifically, it's the Electric Propulsion and Power Lab, which, like the name implies, tests electric propulsion. They're currently testing thrusters in these huge vacuum chambers that will ionize xenon gas and make it into a plasma that's thrust out the back of spacecraft to propel it forward. Like I said, rocket science. Back with John, the artifact he was dying to show me was Apollo moon rocks.
Let's dive in. So the first rock I want to show you is a rock from Apollo 15. So this rock has a name. Its name is 15058.192. The 192 is a section of that sample. So this rock was sectioned off into multiple pieces, and this piece was separated from those pieces. So keep in mind, picked up in the vacuum of space on the moon, and the only atmosphere on Earth this rock has ever seen is nitrogen. We use nitrogen as an inert gas to keep from reacting with any of the minerals in that rock, and these pieces were sealed in this material called lucite. My mom used to wax the kitchen floor with lucite floor wax, right? Similar kind of material, but that's 50 years old. It's been in that material for 50 years, so it's protecting it and has not seen our atmosphere.
And this came from Apollo
15. So that is a Jim Irwin rock. Jim Irwin is the actual astronaut who picked up that rock.
Thanks, Jim.
The rock I'm going to show you now is quite different, and it was kind of special even among moon rocks. Ooh. So this is a sample from Apollo 16. Whoa. This is lunar anorthosite. And an anorthosite represents the older parts of the moon. That's 4.2 billion years old. And the biggest surprise we found in these two samples, and consistently in all of the 842 pounds we brought back, 40% oxygen by weight. The moon is full of oxygen. It's mineral oxygen. It's going to require some work. It's going to take some chemistry. It's going to take some physical and mechanical processes to do that. But it's loaded with oxygen. So.
We have seen some amazing things here on the Glenn Research Center's campus, but now we're talking to Dr. Janet Kavandi, who flew on STS 91, 99, and 104,
Correct.
A full-fledged astronaut. Thank you so much for being here.
It is my pleasure.
So Glenn is one of 10 research centers scattered throughout the country. What percentage does Glenn play in this whole overall kind of push to get back to the moon?
There are, maybe 4 centers that really push the space side, and that would be the Johnson Space Center, the Kennedy, the Marshall.
Right.
And then we are probably next with contributions to space flight.
Well, you guys are kind of important. You're doing propulsion.
Yeah, the propulsion part's kind of, so there's 2 kinds of propulsion too. There's chemical propulsion. So if you see the vehicles launch off the pad, there's a lot of fire and smoke, right? That's Marshall's specialty.
Okay.
And what we do is the electric propulsion system. So I believe you saw.
We saw that earlier,
yeah,
which is really cool
xenon.
stuff.
Yeah, low thrust, but very, very energy efficient.
That is really cool. Now, on the space side of
On
things,
the space side.
you've got Orion working.
We do.
The Gateway.
Yes.
And who knows what else.
A lot of stuff. So let's start with Orion.
Okay.
So with Orion, we have a new crew capsule that will go back to the moon. Under the capsule where the crew sits, there's a module called the service module, and the Glenn Research Center is responsible for that. And it is actually manufactured in Europe, in Bremen, Germany, by Airbus. And then they have shipped the first element to the Kennedy Space Center. It's being integrated with the crew capsule. And then we will bring that whole integrated stack here to the Plumbrook Station out in Sandusky, Ohio, and we will do vacuum testing on that module in the world's largest vacuum chamber. So it's very important to make sure that we test this vehicle properly to make sure it doesn't have any flaws, so that when we put humans on it for the first time, that it will be safe for them to fly.
Do we have kind of a rough estimate of date when that might happen?
Yeah, the equipment will come here this fall and test here, and then we will ship it back, and we should be able to fly by the end of 2020. So
and that's the unmanned mission?
That's the unmanned mission.
Okay, and then between unmanned to manned will be?
Yeah, it will be a couple of years, probably in between. And in this case, we want to put humans on the moon, but we're doing it to stay for longer periods of time, and we're going to do a lot more science. Learn how to build habitats on the moon, how to protect ourselves from radiation, how to grow food on the surface of the moon. And just be sustainable, because what we learn there, we can take and put on Mars at a future date.
Talking with John, he showed us some moon rocks, and I asked him if I could have one, and he so rudely said no, but since you run the joint, can I have a moon rock?
No. Even if I were able to give you one, I would not give you one. I can't have one.
That's right.
So
you
nobody
come
can
first.
have one, right?
All right,
Yeah.
fair enough.
While I didn't get a moon rock, Dr. Kavandi scheduled me a tour of Glenn Research Center's second facility in Sandusky, Ohio, Plumbrook Station. The facilities here designed to simulate environmental conditions found on Earth, in low Earth orbit, on the surfaces of planets, and in deep space. Meeting us in the world's largest space environment simulation chamber is the director of NASA's Plumbrook Station, General David Stringer.
You're standing in the Vibroacoustic Test Complex, a fancy name for a very strong facility, 6 to 8 foot thick reinforced concrete walls.
Whoa.
We have a reverberant acoustic test chamber with 36 horns in it, the most powerful in the world. You want to make sure that the pressure of going into space doesn't somehow snap mechanical components in spacecraft. So you test the shape in a wind tunnel to find out what the force of gravity, the G loads are on a device, and then you can build the device, put it in here, check it against that launch environment, and then inspect it afterwards to see if you've snapped anything. The second thing you're on here, we're standing on, it's called a modal plate, which allows you to find out what the natural frequency of that object is if you don't know it. Everything that's man-made, and even you and I have a natural frequency, if you hit it, it vibrates. You take multiples of that frequency and exploit it on this table here, which can handle 75,000 pounds or so of spacecraft, vibrate it at a G this way, a G this way, and a G1/2 this way. That's exceptional. Why? Because things on a spacecraft might slosh. So we'll test things that have tanks with fluid, full, empty, and half full, because you want to see if there's a coupled effect to you operating on a facility like this. So we can do that. Then when you turn around, you get to see a reinforced concrete door that's 5 million pounds. So on the other side of that, which we can't see today, alas, because it's under vacuum, is the biggest thermal vacuum chamber in the world. It's 100 feet wide, 122 feet tall.
Who besides NASA would actually use something that large?
Anybody who wants to get results in a space that large to fit their spacecraft. We tested the SpaceX's payload fairings. We've tested the Ariane 5 payload fairing built by Oerlikon, now named RUAG for European Space Agency.
Right. So earlier, you mentioned Mars rovers. Have those been tested in the vacuum chamber?
Actually, the inflation bags, the rovers came down in little bags that looked like chewing gum surrounding a rover that would split on the surface of Mars. The bags were inflation tested in the last facility we saw, the in-space propulsion facility. Yeah. And then we brought them in here and slammed them against rocks from Hawaii, pretending to be Martian rocks, on an inclined plane to see if they would tear. The last test was successful after they'd launched both spacecraft to Mars.
Better to know here than up there.
It's much cheaper and easier to fix it before you launch than after.
General, I hear that Orion is coming to town, into this facility. Remind us a little bit of exactly what Orion is.
Sure. So Orion is the replacement for the space shuttle. So it draws on Apollo design in that it has a crew module, which Lockheed Martin is prime for, and it has a service module, a power pack, as Apollo did. The service module in this case is built by European Space Agency. 3 countries, Italy, Germany, and France, based out of Bremen, Germany, assemble the service module. They join in Kennedy Space Center, and that assembly will come here to test. And so through that great big door is where the testing will happen for about 4 months or so.
Wow.
Including about 60 days of thermal vacuum test to do 2 thermal cycles, super hot, super cold, and then once again to make sure that it can stand the cold and vacuum of space. And then not at a vacuum, just in the space that it's in, it will get electromagnetic interference testing, sparking radio waves in to bathe the spacecraft in that radio wave and see if the spacecraft electronics, the avionics, are interrupted in any way.
Okay. That is really cool stuff. I love how much goes on here. NASA is great about sharing their facilities and their knowledge with other companies and other countries. That is a win-win for everybody.
It's one of the most significant milestones in the field of aerospace. And even 50 years later, the accomplishments of the Apollo program are still being celebrated around the world. From gaining incredible insights from NASA icon Gene Kranz, to visiting the boyhood home of Neil Armstrong, and even seeing what NASA has in store for the future, we've taken you behind the wings of the Apollo program.
Hi, I'm Matthew Burchett.
I'm Gene. The awesome drive from Wapakoneta to, say that fast, doctor. Are you a doctor?
No.
Okay. We were on a roll. Mr. Ben.
We're now on a B-roll.
Yeah.